So in this module, the primary focus is talking about the vSAN stretch cluster and two nodes cluster. Okay. Primarily for both kind of cluster, we are requiring the witness node. Okay. So we'll talk in details. Don't worry about it. So vSAN stretch cluster, the primary thing is like if a customer asks like where we should refer the stretch cluster solution. Okay. And how we can deploy it and all we will be discuss in details, right? So it's simple like you can implement in case of where you want the disaster avoidance from any of the site or a swift disaster recovery solution. Okay, when I say swift disaster recovery solution, it means that a customer is looking kind of a primary site and DR site, and they don't want to spend the amount of kind of any DR solution, kind of your SRM, maybe Zerto, maybe another DR solution, whatever being used is by VMware. Okay. So they want to make a DR solution between the two nearby two availability zones. Okay. Like this is AZ1, this is the AZ2, and like the VMs which are running here. Okay. I want to protect them. In case of disaster will happen, my VM should be come up here with the minimum downtime. When I say minimum downtime, I don't need to invoke kind of DR here, don't need to wait. If it will detect some kind of failure to be on this side, to be on this side, it will, I mean, the VM should be bring up on the secondary side. Okay. So that kind of scenario, we prefer to go with stretch cluster. A two node cluster is implemented in the environment where we like we are planning some kind of remote site. Okay, we are planning some 10 VMs, 20 VMs. Okay, not more than that. The smaller sites on the remote site and the even by edge location itself. So we can go with the two node cluster configuration, right? So two lessons this module have: vSAN stretch cluster and two node vSAN cluster. We'll be talking in details. Don't worry about it. So the first lesson where we will be covering the characteristics of vSAN cluster, stretch cluster, discuss about the architecture, key use cases, explain how read and writes happen in the stretch cluster, and the networking requirement for building up a stretch cluster, not only networking, rest of the requirement also. Describe the purpose of vSAN witness and how it's important to maintain the availability in your vSAN stretch cluster. All right, we good so far?
Yes, sir.
All right. So when we say vSAN is stretched cluster, right? Some of the time people are get confused like, are these two clusters, sir? No, this is a single cluster that is stretched over two geographical locations and that supports the site level failure. When we say site level failure, it means that if this I referred as site 1, this I referred as site 2, okay? If site 1 got failure, then all the VMs which are running on site 1 will be restarted to site 2, and it's vice versa. It's not like that. I can use in any way. I can use active, standby, active, standby, active, active, kind of that. Okay. So this is a single stretch cluster that is stretched over two physical site. It support max 20 host per data site. By default, my standard cluster size is 64 node, but with vSphere 8, it support total 40 hosts in both the sites, 20 hosts per site. Wow. Earlier in vSphere 7 version, it was 30 maximum. I mean, 15 node in each site. Okay. Witness site to work kind of a quorum. Quorum is kind of some decision-making authority. Just to check the health of my both the sites running and active. Okay. It's a witness, right? He'll check this is okay, this is okay. If there is some problem occur here, what I need to do, and it's a kind of decision making authority that point of time. Okay. Maintains the object availability for a failure within a site and of a site. What it means? Maintain the failure availability. It means that maintain if any failure happen locally, it can be protected within local site. And if entire site failure, how it's got protected to the secondary site. So vice versa again, it maintain the local failure here, and it also maintain the failure if this entire site goes down, what will happen to the data site to itself. Okay, so the three types of stretch cluster topologies having the following additional benefits. One, connectivities restore a sync is performed to make stale components active again. VMs are migrated according to their configured vSphere DRS rule. What it means is three type of stretch cluster topology. What it means have the following additional features. Three types where we'll talk about kind of the different type of failure scenarios. Okay, why it's a three types of topology, like it could be a failure, it could be a failure, or it could be a failure, right? So in any case, if it's failure is still my data safe, if this failure is still my data safe, if this failure still my data safe. Okay, but out of three, if any two will get an simultaneous failure, that point of time I am on risk, my entire data is unreachable. Got it? And any kind of site failure is maintained by the DRS rules. While we say the DRS rules, we'll talk in details, don't worry about it. Like sometimes we give the preference VM should be run on primary site as per my DRS rule, the placement policy for the VMs. If this got failure, the entire set of VM will be rebooted here. But if we'll come back, site in healthy state and come back, my VMs will be revert back. So the placement of the VM, okay, the placement of the VMs on particular site is taken care by the DRS rules. Okay. We good so far?
Yes, sir.
Okay.
Sir,
So
one thing I want to ask, like when one site goes down, say for some data center, some natural calamity happens, and the data center goes down. When the VMs would get powered on the secondary, it will be an HA condition, right? It is not live.
absolutely, it's a well, the failure events is depend upon the storage policy first, what we have applied on across the site. Okay, the replication protection, and it's a kind of HA. Absolutely right. HA
And
will
when the
start
site
the
comes and when the site comes back, sir, the VMs would just V motion, right? When it comes
absolutely
back, then it will be online only. It is just when it fails, it will be an HA, but when it comes back, it will be a live migration back to the
yeah.
primary site,
That's all being taken care by this.
DRF.
What is
Okay.
your VM's placement rule? Okay, allow me some time. I'll talk in detail about DRS rules as well. So vSAN stretched cluster networking. That's an important thing while we are planning kind of networking solution. So from primary site to witness site, there should be a L3 connectivity maintained. Okay. And my latency to be 100 to 200 ms. While I say the 100 to 200 ms, if I'm using up to 10 hosts, 200 ms latency is okay. But if I'm using more than 10 hosts per site, then it should be equal to or less than 100 ms. Between the site, the direct, this is the one, direct connectivity. So stretched L2 does not support the static route. L3 static routes between the site, and this should be happen less than 5 millisecond. Okay, when we say stretched L2, this is the stretched L2, and this is the L3 communication. Okay, end of the day, this is my entire single cluster. Correct? When I say single cluster, it means that kind of my management VLAN. Okay, management VLAN is common for both of them, and the kind of vMotion or kind of vSAN we are using over L3, both the sides that should be routed to my primary sites. Okay, my vSAN, vMotion kind of track, those should be routed. So witness, if we'll talk about what could be a witness could be a directly physical server, or a witness come in a form of virtual appliance also. When we say virtual appliance, it's more over your ESXi, but not exactly ESXi. This is especially a build purpose of appliance for witness that you can download directly from the VMware site. And you can deploy just as a VM, you can assign a management IP, and also you can connect this one within your vCenter server, any of the site. And the recommendations to keep this appliance somewhere on any third site. Okay, third site means so that it can easily maintain the core. Okay, if this is my availability zone 1, availability zone 2, maybe site 1, site 2, this should be placed somewhere on third site. Okay, if you will place it on, like for an example, site 1, if site 1 entire goes down, then automatically my this go down, witness goes down, then your cluster will be completely down. So that's why it's mandatory requirement to keep it on third site. But for the moment you are building up some cluster and you don't have the third site, you can put on any site, but it's a risk during that time. And later on, you can change your witness and just to replace it with the third site witness. Changing witness ideally will not make any impact on your cluster, no downtime. You can change it at any point of time. Okay. So again, as I said, it's just like an appliance. You cannot kind of any VMs on that, and each cluster require one witness. So normally in witness, there is no redundancy, no kind of HA. But yeah, on witness appliance, you can do like if the in third site, you are using a entire set of cluster, you can enable kind of cluster level HA feature. This could be goes down for the time, and it could be like for the host level, it could be a restart. But during some time, if witness is not available, that is fine. But especially on third site, if you are using a cluster, always give the high priority to be restart to another node. Okay, because there is certain heartbeat time. It can be for the moment, if it will restart for the time, that's we refer as split brain situation. No failover will be triggered. Okay, like just assume a scenario. My witness appliance on a chain enable cluster on third site, and this host goes down. This witness should be restart on another host, right? So that point of time, what will happen? You will think like, sir, it's being restarted. My cutover will start from primary to secondary, secondary to primary. Answer is no. That's refer as split range situation. Which VM is available on which location, they will keep on running. Okay. So again, as I tell, it is just an appliance on any of the host on third party site. You can run it up and you can deploy. And once you'll put a management IP to that appliance can be available within your vCenter server. Okay, it will show like of it, whatever name you have given. It is an appliance, but actually in your inventory of vCenter server, it's not like a VM. Whenever you will add just using the management IP, it will show just like another ESXi host. But ideally, it's not the complete ESXi host. This operating system designed and built only for maintaining the witness. Okay, not the entire ESXi host. Get my point?
Yes, sir. Yeah.
So vSAN witness node size, when we talk about, it's all matter like how many components being supported, like tiny size 750 components it can manage to store 10 VMs. So we have to see like how many VMs we are protecting. So ideally we should go large or XL size. where it support, enterprise level of components and enterprise level of failover for the VMs. So it will show us when we'll deploying the appliance, vSAN witness appliance, it will show us the what size we should take. Okay, so it is just an election of witness. So when we say vSAN witness node selection a part of the deployment, choose the witness node deployment at third-party site and just elect during the cluster creation, you can elect the witness. So making the stretch cluster, there is two way. One is in a startup itself, you have set it up all the prerequisites for your environment, your witness appliance, IP address, you have configured all the VM kernel, required VM kernel ports for that. Then during the creation itself, you can select vSAN stretch cluster. And once you'll select the vSAN stretch cluster, it will ask you to create the fault domains. Okay, what it means about the fault domain means how many hosts will be available at primary site, how many hosts will be available on secondary site. Then next step, we will select the witness and claim the disks for witness host and review. When we say claim the disks for witness host, it means that is how many disks you will use kind of the management and kind of maintaining the witness traffic. Okay, these are the disks available locally within your that is not a disk group or disk claim disks is happen already on the host level here, and this is the claim disk for the witness host. Review and finish it. Okay, then your cluster will be created during the stretch cluster creation itself. But if you don't want to create an stretch cluster first you have create the standalone cluster, later on you want to stretch that's also possible. Later on means you want to do it manually. Manually means first you have making a standalone cluster, and later on like you have had three hosts you have already on the local site and three hosts you have added from the remote site. Now you want to make it as an stretch cluster. So these all steps you can do manually also. You create your fault domain, add the host from primary site, add the host from secondary site. When you will be creating the fault domain, it will ask you for creating the witness disk selection, and you can do that later also, right? That's the important phase. When we do the witness traffic segregation, it's an prerequisite. We have to enable it already, right? So beside the native VM kernel traffic, the native vSAN, native management, native vMotion we are using for host level, we have to dedicate one VM kernel for just to use to access the traffic for witness, just to reach to witness. Okay, a witness VM kernel should be created. So it means that like this is my, just assume this is my witness appliance. Okay, this is my one of the, not only one, there could be 2, 3, 4, how many hosts? For each host, this is my L3 routing actually. Okay, this will go here, this will go here. That's how my host is talking about, right? So this all is my L3 routing. When I say L3 routing, I have to define a VMK specially for witness. Okay, I have to make a VM kernel port separately and assign them as a witness. VM kernel port, assign them at witness. A VM kernel port, assign as an vSAN witness. Okay, all three should be done, and a L3 routing should be happen just for the witness communication, where we just talk about it required 200 ms latency for 10 or less host. If 10 or more host, less than 10 host, 200 millisecond, 10 or more than 10, 20 maximum per site, it should have less than 100 ms latency, right? So this should be enabled. So it's all matter like where we want to enable it. Here in this diagram, they have showcases they have enabled the vSAN witness on management port itself, but my preference, you should go on a separate one. Okay, separate one. When I say the separate VM kernel port, especially for the vSAN witness communication. when we talk about the enterprise production environment, right? So this witness traffic, ESXi vSAN network IP address -I. IP is you will giving the IP address of that VM kernel port I, VMK0-T witness. Just prefer that as an witness. Okay. So however, you can now if you will see here enabled services, once you will run this command from message putty, and we have to repeat all these steps from each and every host. Okay, just to assign the witness traffic. Okay, now they have showcased you like they have enabled on VMK0. Now you can see on VMK0 here, 2 services being enabled, right? But again, as I said, you can create the separate VM kernel port from UI, that is fine. But the vSAN witness, you have to enable from the command prompt, right? Not from UI, because in UI, you will not see the vSAN witness VM kernel type. You will see the VM kernel type, create a VM kernel type, give the name vSAN witness, don't elect any of the function from there, okay? Go in a command line and just assign that function as a witness.
So is it a function or it's just a name that is happening in this command?
It is a prerequisite actually you have to enable. Otherwise, you will not able to initiate the witness communication, and it will not reach to your quorum. I mean the witness appliance. That's a kind of mandatory requirement. Otherwise, your stretch cluster will not be successfully created.
Okay.
So witness traffic segregation providing the following additional feature benefit of VM kernel adapter within vSAN allow to it support jumbo frame also. When I say jumbo frame, we can enable 9000, but for that all my L3 switch port and all jumbo frame should be enabled on physical device as well. Okay. If you will not enable, then you wouldn't be able to see. Support the ESXi CL command, add an IP address to the vSAN. Yeah, through ESXi CLI command, you can go ahead and you can add the IP. I mean, the entire task you can create a VM kernel, assign the VM kernel port IP and all that you can perform through the command line interface as well. So that's an important thing about the storage policy when we have talked a little bit earlier also, but especially on stretch cluster, when we say site disaster tolerance, okay, so we have to select site mirroring stretched cluster. Okay, what it means is whenever my data will come, then any of the data write happen on the VMs, it will happen on both the places. Okay, that we choose. Non-standard cluster, we should not choose it because we are talking about here site disaster tolerance. When you talk about site disaster tolerance, site mirroring is stretch cluster. Post mirroring we can do. Then this is the default. This is the one which is being showcased here. Then we say none, keep data on preferred site only. It means that whatever write data is happening, like for an example, for the moment this VM is active here, my data will be written here only, not here. Same way, we'll say keep data on secondary stretch cluster. If my VM is active at the moment on secondary side, data will be right here. No mirror copy at all. No mirrored copy at all. Okay. None stretch cluster means we are talking about simply the standard cluster. So we are not writing any data for the site disaster tolerance. Okay. And from second tab, failure to tolerate, where you will like you are seeing here. Let me just check if they are given. No, not a problem. Under this, you will get another list kind of FTT1, RAID 1, FTT1, RAID 5, FTT1, FTT2, RAID 6, FTT2, RAID 1, FTT3, RAID 1 kind of that. Okay. So this second type of policies let us telling us how you are protecting your data locally. So once your data is here, your VM is, for an example, the VM is activate by default here. When I say active, it means that as per DRS rule, this VM is running here at the moment. however underlying storage, how my data will be protected locally. So it will depend upon what is the local failure to tolerate policy I have applied. For an example, I have applied local failure to tolerate policy FTT1 RAID 1. It means that it will create one duplicate copy here, and also it will create one duplicate copy here. Again, if I'm writing 10 GB data, the total consumption here is 40 GB. Okay. Got it? So with this
Yes, sir.
cluster, we have to decide how we are protecting the data across the site, and along with this, how we are going to protect the data locally on this particular site where we are enabling the stretched cluster, right? Got it?
Yes,
But
sir.
Yeah. Yep.
So some of the cases we could see, sir, yeah, that's fine. I have made the stretch cluster, I am okay. But within a stretch cluster, I have the 100 VMs, but I don't want to protect all of the 100 VM across the sites. That could be a use case, right? I would say out of them, sir, 50 should be protected across the site, but still rest of the 50 VMs, I just want to protect locally, don't across the site. At point of time, you can pick any of the policy, right? And you can just apply on your stretch cluster. Definitely local policy will be applicable with that. So when we say dual site mirroring, that's what we are talking about. Dual site mirroring means by default it's applying the RAID 1 FTT1. What's happening here? Any data is being written to the VM by this policy. It will go kind of C1, C2 witness, C1, C2 witness. Okay. So stretch cluster maintain one replica on each data site, and also like the whatever local policy we are applying. Then when we say site mirroring of RAID 5 FTT1, it means that it's going like data parity, then again data parity, means the same replica, whatever being happening here, same replica is available here also. Correct? Get my point?
Yes.
Yes, sir. But in 1.3x, right? We used.
Sorry, Sarwan, what you said?
No, in this scenario, we can say up to
Yeah,
1.3. Yes.
locally. Two times upper means is what? Because my across the site is equal amount of copy, right? So if I'm writing 10 GB data here, so it means that it is around 13.33 here, 13.33 here. Got it?
Yes, sir.
Because it is across the site, it is not locally, right? Whatever is the data written here. Okay. So simply we could say within a stretch cluster, we have to planning by default 2x capacity at least, whatever we are planning for a standard cluster, right? Because it's making the exact replica on secondary site. Okay. So when we say the read and write, so VMs perform 100% read always from the local site. Okay. And wherever my VM is active, whatever the reads will happen, that will happen from the where my VM is residing. And write is always happen both the sides in a synchronous manner. Okay. Synchronous means if I'm writing a 5 GB data, this 5 GB go here, here, parallelly. Okay. So now let's talk a little bit about the failure scenario. What happens if uh, different failure scenarios comes in picture. So when a network failed within vSAN stretch cluster, when interruption happened between preferred and secondary site, that is the first scenario. Okay. If a disconnection happens here, what happens? A vSAN stretch cluster can tolerate one link failure at a time without data becoming unavailable. A witness site serve as a tiebreaker here. Okay. Then issue data to data sites connectivity. In this example, the witness would elect as a preferred site. It will see which is the preferred site. Any VMs of the secondary sites are restart it on the preferred site in accordance to with my HA configuration, right? So what will happen? If this disconnect will happen, it will elect one site as my preferred site, and what will happen? All the VMs will be rebooted to my preferred site.
So in
Second,
this case,
yeah,
which one is which network is it that would consider to be as a network failure? Like for example, I give you like what happens is sometimes we have three VM kernels, right? We have three separate networks or four separate networks, and one of them will go down, okay, and then still we'd see some connectivities there between like the date, like for an example, the vSAN link is up, but the management link goes down, or vMotion link goes down. So which particular
yeah, correct. That's a right ask. So it's all matter, like especially for this link, okay, this one, okay. So which particular network kind of we have done the routing. So in this scenario, you are talking about kind of management or my vSAN, okay. Management is up, vSAN is not up, correct?
Yes, sir.
Or vMotion. So vMotion, yeah, vMotion is something in the host level, correct? So it's all matter about my vSAN stretch. That's the one, is the important one, which is being stretched over L2 for vSAN communication between cluster 1 and cluster 2. If that goes down, it means that the hosts are electing that. So that's the one thing, right? The vSAN one is primary, but if I would say the complete disconnect means is they are not talking at all, right?
Yeah.
Primary side is not talking at all to secondary side, okay? That point of time witness will consider, but here the primary one we refer as the vSAN channel break between these two. They are not talking about over the vSAN traffic, okay? It's more over same. If we talk about the local cluster failure scenario, within local cluster, what is my channel for storage? vSAN, right? Correct?
Yeah.
And especially for the, when we talk about HA, in case of my vSAN network is available here. So just assume a scenario where non vSAN environment, we have 3 nodes, okay, and we have this management network, okay. This is my management network. This is my non vSAN cluster. So how the HA trigger here? How
Any
source
host
gets to
goes down.
know, like this, let's suppose this is my master, this is slave, this is slave. This slave is not available for the moment. How this master will get to know? Through
So
heartbeat,
that, yes,
right? Through heartbeat, okay. And how this host is getting heartbeat?
data for
My management network.
management and data for both.
Management, and my secondary is my data store. Correct?
Yes, sir.
In vSAN topology, my heartbeat is always my vSAN data store. It means that this is my vSAN traffic, which is working here for as an heartbeat, even for triggering the HA always. Okay. My vSAN network referred as in my heartbeat network. So same way here, we're talking about the set of hosts. Those are goes on secondary side. It means that these are the part of my here logical segregation is not one host. Here logical segregation is your fault domain. Okay. Here a set of logical hosts are here fault domain. So if one FD is not coordinating with another FD, over the vSAN network, it means that over the heartbeat network, continuous 3 heartbeat is not getting approximately 30 seconds, I believe that is the time. It means that will consider the it's not available, then witness is the decision authority to whom it will make the. However, this is just a network break. This is a kind of network isolation situation, right?
Yeah.
This is not something like we are talking about the entire site. This is just a network break. That point of time, my witness will take the decision. That's not something we will take. Witness will take the decision where I should prefer as a primary or preferred site. Then VMs will go and restart to that particular site. It could be my primary, it could be my secondary as well, right? Because it's not the entire site failure. It is just a network channel break. Correct?
Yes, sir. Yeah.
So moving to next scenario, where it's talking about the the preferred site lost the communication between to witness and also to secondary site, right? So it means that this channel is break, this entire channel is break. So it means that I'll consider, then definitely witness don't have any choice because it is not talking, and secondary will become as in my active site, and the VMs which were running here, they will be restarted. They will be restarted to secondary site. Correct? Let's assume a case where connectivity being restored after some time. Okay. So what will happen for these VMs? Will those be restarted back? No. A vMotion will happen as per DRS rule. Let us suppose for an example, the 50 VMs goes here, and all these 50 VMs we have make a rule. The group of these 50 VMs should run to group of these 4 nodes. Okay. It means that one site will restore, then these VM get back to this site, and this will happen through the automated vMotion. Okay. So the next, are we good?
Yes, sir. Yeah.
All right.
Yes.
So the next scenario is talking about the vSAN stretch. Only my vSAN, my witness communication will lose. So what will happen? No failover will trigger at all. The VMs are running on primary side will be keep on running. The VMs are running on secondary side will be keep on running. Okay. Once witness will come back, then my communication will restart back. Definitely it will show some warning about the witness appliance. It's clear? No HA event would trigger.
Sir, I have a question. In this case, both the sites there of the VMs are running. Okay.
Yeah. This
But
could be. Yeah.
but in terms of the VMs being accessed by the users, like they are connected to the preferred site. For an example, one user is connected to the preferred site, and the witness node goes down, and the
Data
secondary the secondary VMs are also like running, but
they are
on
writing
the
some data. Yeah.
but so the connection would still remain to the preferred site because the secondary, because both the VMs sorry sir, I'm not able to put it right how to say, like both VMs are running right on secondary and preferred.
Wherever those are active, those will be keep on running.
Those connections would remain active as
absolutely.
This
Because this connection is active. Wherever my data read and write was happening, they will keep on continuing. Only the problem is, if after witness this goes down, no failover event will occur.
Right. Okay.
Still, my read and write mechanism will be same as it is, even in absence of witness. Okay. Because witness is not something is deciding my data writing or reading path, right?
Yes.
It is just a vote. It is just a decision authority. It is a kind of judge, Witness is witness, like in whom favor you will give the decision, he will be preferred one, right? But if my witness is not available, he is happy at home, he is happy at his home, right? But if any
Yes,
failure event will happen, then like for an example, this is break or this entire site got failure. No failover event happen from secondary to primary. Same way, this site goes down, no failover event will happen from preferred to secondary. Correct?
yes, sir.
Adaptive quorum control is one of the advanced enhancement. It especially helps us if in case we are lacking some of the I would say witness, I would say votes, especially the votes, special when some failover events happen within the local site. And I feel like the sufficient votes are not available to maintain the failover, then your witness appliance stand up and he say, hey, no worries, I am there, you still are okay. Let's understand this scenario. So let's assume the first scenario where how it's handling. So it is focused on the local site failure, right? So until unless we have the sufficient vote within local site, I don't have any problem with the failover, right? So what is the failover condition in any kind of policy? Like if I would say in locally, I have applied FTT1 NAD1. So how FTT1 NAD1 write the data? C1, C2, witness, correct? And what is the condition of maintaining the data live? Keep the votes more than 50%, right? That is my condition. My votes should be more than 50%. So it means that my data is accessible. So if I would say component C1, C2, and witness, with this policy, how many total votes I have? 1, 2, 3. Any two will be live. My data is accessible, right? Because total vote is 3. So who will win? Where my 2 vote is active. It could be C1 or witness, it could be C2 or witness, it could be C1, C2 altogether, right? More than 50% votes should be live at the moment. It means that I'm okay, my data is accessible, correct? See here, it is just the same scenario where we say in my one of the site locally, this component is got failure. Am I still able to reach the data locally? Answer is yes. Case I have this is live and this is live. Okay. I have 2 votes are live so far. I am okay. But the magic of AQC is the C here. That's the important thing, right? So when we say if witness have a failure or network outage, host 1 is still enough. If the witness means it's a local witness. It's a local witness. It's not your quorum or witness. It's a witness of local component within site. Okay. Get my point? It is not the vSAN witness. It is your local component level witness. The local protection. Now you would see here earlier scenario out of 3, 1 go, no issues. Why? Because I have the sufficient votes to survive the data within local site. Next scenario, vote 2 is here. This is the one which C1. This goes down. This also goes down. Now what you tell, what will happen? Can I access my data still? Yes, absolutely. You can access because these are also your votes. Okay. This is your party, right? Which is happening on secondary. So what will happen? Any of the component will come from that side and it will vote because altogether this is you who is stretched over there. That's not a problem. These are your mirror copy, right? These are yours mirror copy. So it means that within local site, if still my 2 watts got down, my data is still reachable and accessible, because from another site, there would be the components which is being written on other side, they will watt and they will keep you active. Again, you have watt 1 and you have 1 watt here 2, still your data is accessible from the locally. That's the magic of AQC. If I would just talk about, just leave it secondary side for a moment. If I would talk about only this environment, and I would consider 2 component got failure, that point of time, my data is unaccessible, no data accessible. I'll consider it as a failure when I'm using the FTT1 rate 1. Same way you can apply for another policy also. So AQC say, for voting purpose, I have the sufficient component for another side also. They would vote and they will keep you live. But if will say, sir, this is got also failure, then what happens? यार तीनों ही host fail हो गए ना, तो तीनों host fail हो गए तो it's a site failure, right? Get my point?
So,
it's a site failure. If it's a site failure, then definitely my VMs will get restarted here. But in
sir, to understand this AQC concept, basically, so we have stretched cluster in this, what we are seeing the screen. We have stretched cluster. One site is preferred site and the secondary is there.
Yeah.
Now, if 2 components fail, we have only 1 component here, and that component will still be active because all of the all of the 3 components are still active in the secondary side.
Secondary side, right?
But to use this feature, basically, ideally, should it not happen like when 2 components have failed in the preferred side, and as per logic, like what we say,
Yeah, locally,
about
so it will
FTT1,
definitely goes. I mean, within standalone cluster, definitely my cluster is, I mean, cluster node is okay. See, one moment.
So only if we enable AQC, then only this will happen. For an example, let me rephrase it. If AQC is not enabled, then in this scenario, on the preferred side, if two of the nodes go down, and I have only one, and AQC is not enabled, then this VM will become inaccessible, and it will move the VM will restart on the secondary side. If AQC is not enabled.
So in this case, like end of the day, yeah, my VM is active here, right? Any of the host,
yes,
right?
Yes, sir. Yeah.
My VM is active here, and my writes are happening both the sides parallelly, correct?
Yes, yeah.
Because write is always happen on the basis of the across the side policy, whatever I have given, correct? If it's across the side, then definitely my writes will happen for both the sides. Okay. So in this, yeah, if AQC is not available, yeah, that point of time, this, yeah, unaccessibility, though I don't think so it should go, because end of the day, these are the mirrored clients of it, right? Because my write is happening for both the side. But yeah, definitely a read could be a challenge that point of time. If I am
I mean, sir, if in case this VM was writing on the preferred side, it has been accessing the preferred side. And what happened is 2 of the components, 2 hosts goes down, and then obviously we have only single component available now.
Yeah,
and AQC is not enabled. In this case, the component with 1 component with this FTT1 RAID 1, the VM would not be working fine, right? Because the components have failed and the data, the policy is not working.
Yeah, my VM should be inaccessible, but due to this stretched one and AQC, I actually need to check either I believe it's by default enabled. Okay. In case of a stretched cluster, because again, it's a native feature, and that's being, I mean, all my replica component are exact copy. Whatever I'm writing on the 3 hosts, the 3 hosts are writing right here. That means
Yes, sir.
at this point of time, my policy has been written 2 times, right? Because
Yep.
of 2 times, still my VMs feel safe. Yeah, I don't worry. Still, if I'm not able to accessing from here, I could able to access. I mean, from what's perspective, my components are still available here. However, whenever these component will be come back, I'll follow the process of data resync, right?
Yes, that's this one. But again, sir, like
On AQC, let me check it. Either we have to enable
okay,
it or it's a native feature. I
okay,
believe
sir.
it's a native feature from 8 onwards, what I think of.
Okay, okay, sir.
Yeah. So this is the, we good now? Can I move ahead?
Yes, sir. Yes, please. Yeah.
No. So DRS awareness for stretch cluster, that's the important point, like what we are discussing. Primarily the thing, how do we plan the DRS rules? So DRS is a native rule that it will do automatic VM migrations and all. The main thing what we have to understand here is how do we need to plan the DRS? Until unless you will not plan the DRS rules, you wouldn't be able to find like, yeah, which VM will placed where. For an example, you are creating a VM here, right? Within a cluster. Okay, so it's not guarantee whether it will run here or it will run there, right? Same way it will go here until unless you will not define some VM2 host affinity rules, right? VM2 hosts affinity rules, right? So if you will say set of these 50 VMs should run on, never make must run rule. Keep in mind, either will make the must run rule, it will be a problem for you. It will not make a failover, right? 50 VMs to these 4 hosts. Okay. So how you will be complying or how will be compliance against this rule? What you have to do is, like you have select these 50 VMs should be run here, or either I am creating a new VM. So during the creation of VM, don't elect the cluster always, just elect the host of primary site so that they should go. Or anyway, it will keep the placement, and later on, these VMs will be the part of this particular, should be the part of this particular VMs group. If you are making the new VM, if you have an existing VM, then you don't have any problem. Automatically, it will detect the VM group of host. You have make a rule should run. It means that by default, set of these 50 VMs will be here on my preferred site. Okay. Same way, again, it's matter. If you are using this active and standby, then this rule is enough. But if you are saying, sir, I want to use it for 50 VMs, I want to use it active, standby. What will happen in this case? For just assume a scenario, this site goes down for the time, VMs will come back here, all 50 VMs will be restarted here. Once my site 1 will resume back, these all 50 VMs automatically will take the vMotion here, because as per your rule, it is a should run rule. Should run rule means is it is preference to be run here. If these are not available, they will jump to secondary. When they will jump? Once my primary is not available, right? That's why I say never make the must run rule. If you will make must run rule, if this site goes down, VMs will not take failover ever, because you have made a must run rule. You have made a highly forcefully affinity rule here. For some of the sites, VMs, if you are using this active, this is standby, it means that is, yeah, same rule you will make here, like for another 50 VMs to set up this, then you will apply should run rule. So it means that rest of the 50 VMs where I'm referring this site as an active, this site as an standby, I will make a should run rule. VMs, these 50 VMs should run on a secondary site, right? Same it will follow. If it will gas down, VMs will be back restarted here. If site will resume back, VM will be back to secondary site, right? But the most important thing here is Storage part, everything we are okay. Definitely you'll be getting as per the storage policy. What about the storage? Now we'll talk about CPU and memory. Okay, that's the important thing, right? When we are making any kind of stretch cluster, we always reserve 50% of amount CPU and memory for the entire cluster. It's not only you are getting half of storage, also you are getting half of CPU and memory. That's a mandatory one, right? Otherwise, your failover event will not happen, because your failover event does not only rely on storage availability, it's also rely on the CPU and memory availability. So it means that if I am using a 40 node cluster, out of that, your 20 nodes resources will be reserved fully just to maintain the failover, right? Get my point?
Yes, yeah.
Yeah. So in admission control policy, we should always define 50% resource reservation, CPU and memory. Your storage reservation will be automatically happen when you will apply the across the site policy, like FTT1 kind of red one for mirroring across the site, right? So that's an important thing we have to keep in mind. But yeah, so this 50% resource should be always fixed. I mean, should be reserved whenever we are maintaining the site level failure, right? Either we are using this active, standby, or either we are using this active. If we are using both the site active, then total provision should only happen 50%. Automatically, or it will show you warning kind of alert and all. If you will, in admission control policy, you will set it. If you want to create the VMs, something or like that, it will show you the unavailability of CPU and memory. Same way, it's an standalone cluster. Standalone cluster, like typically we do one or two node failure depend upon our design plan and design decisions. Same way here, you have to plan in that way. That's an important thing we have to keep in mind. Yeah, DRS rule is always the mandatory thing. So we have to keep in mind, like, how do we plan? Yeah, so after resync complete, DRS will move based on the DRS rule. That's what we have discussed. Okay. So changing witness or replacing witness is not a big deal. You just, for an example, I took one example, like initially during your cluster deployment, you have just planned like, for the time being, my third site is not ready, but I want to keep a stretch cluster. That's fine. You can keep your witness on one of the local site, then later on you can change or you can replace. Okay, there is no redundancy being set on witness. How witness being protected, that I told you, like witness can be protected by just make some HA rules. If you have multiple ESXi host, again I say, if my witness is unavailable for the moment, for some time, for the hours, it's not going to be a big risk for your environment. Your VM will keep on running. Okay, if you are sure, like I'm not getting any failure both the side, that's fine. The time being, then like you have built witness locally for particular site, later on you can change it to third party site as well. The some of the things for my witness should match with the ESXi version I am using with the witness cluster. Okay. So this is my stretch cluster health. We can check, like site latency is the major problem we feel. So here you could see preferred to secondary site, my observed latency is 0.3 second, 0.36. Threshold is 5 ms. Preferred to witness, latency has been less than 1 second, where threshold is 200 ms. Secondary to witness, 0.7, less than 1 second again, where this is the one. Again, the threshold value is like, if I assume this witness, primary, secondary, this should be less than 5 seconds. This should be less than 200 ms. In case of less than 10 nodes, okay, if more than 10 nodes per site, it should be less than 10 milliseconds, right? So the site latency itself, we can check from the Skyline app. Yeah, here is some lab for stretching the cluster and simulate the site failure. Site failure means either we can just restart, shut down one site node or disconnect. Okay, examine the VM storage policy compliance. We'll be doing the lab, don't worry about it. Replacing vSAN witness host, it's pretty simple and straightforward step. Change the witness host, but again, my all witness prerequisite should be pretty well configured. Then we can change the witness. Okay, next is two-node cluster. It's not take too much time. Let's finish this, then we'll take a short break. Two-node two-node vSAN cluster. We can design and deploy the environment where we should have deploy a small set of VMs. The max count is 225 VMs. One witness host as an alternative location should be available here. Two hosts can be directly connected to each other, means where we are making up a setup of two hosts. We don't require any kind of Tor switches for them. We can make a direct connectivity just for fast access of data and communication, right? And a witness could be somewhere on third site. It could be your main data center, or if you want to prefer to make another third site, you can make it. That is also fine. But better if you have the main data center, just put the vSAN witness appliance over there. So again, the requirement within the local site where we have make the layer 2 connectivity, this layer 2 connectivity less than 1 ms second, and where we have the witness, it's less than 500 milliseconds. And again, we have to make witness VM kernel the same way we do with the stretch cluster. The same command that we have run earlier also, we have to configure. So again, we have both the choices. Either we can make the host direct connectivity. We don't need, because we are using a small site, right? And if within a small site, we are purchasing a switch and all, then it's not a cost-effective solution. So we can make a direct connectivity. Direct connectivity means just take a cable. If you have one or two on the network cables, you can make the direct connectivity between them, right? Or again, if you have some switches and all, that's fine. You can make a layer 3 connectivity by layer 2 or layer 3 connectivity by using the external switch also, right? So that point of time, again, kind of witness appliance, you have to configure the witness connectivity by referring. Again, you have to configure a witness port separately, or you can give your network, your management network itself witness. So a shared witness can be used, a vSAN shared witness, where we are using the common cluster two nodes, especially on two nodes cluster, we can use a shared witness also. Again, this is the size, the VMs and component we are going to write. According to that, we have to make the size, CPU and memory for the witness appliance. So two node cluster, again, when we start up to build the two node cluster, then we have to choose two node cluster. And again, it will ask, what is the policy we should make? We can make FTT1, RAID 1 mirroring with FTT1, not beyond that, because we have only two. How it will write the component? It will write C1 here, C2 here, and witness component will be written on the witness appliance, right? So we cannot go beyond this policy. Okay. And again, out of three, any two should be active at the moment. Okay. So we can configure some nested fault domain just to protect the failure, the entire disk group failure kind of that. So we can make fault domain on disk group level. Our disk group level will be factor as by default. Within fault domain, we add the nodes in like when we make the actually stretch cluster, 6 node, 8 nodes, 20 nodes, 40 nodes kind of that. But here a disk group can be referred as a logical fault domain. So what is the advantage of it? Just for an example, if one disk group got failure, another disk group just factoring as a within the host, another disk group is factoring as another fault domain. So I can replicate the another policy, kind of FTT1 RAID 5, FTT2, FTT3 with RAID 1. But again, for that, we should have the sufficient fault domain. Okay, and how we can create because two nodes, if we'll go node level fault domain, only I will be able to create 2 FT, right? But if I want to go more than that, a disk group can be considered as one fault domain. So I should have the enough fault domain to maintain that policy. And how we can create our disk group can be considered as one fault domain. Okay. We good so far?
Yes, sir.
All right.
Yes, sir.
Cool. Yeah, that is, I mean, we can configure two node cluster where a witness should be available, a L2 connectivity should be there. We can do that. Yeah, we'll be performing some lab. And that's it for this module. If you'll have some question, definitely we'll take. Especially for an AQC, Banu, I believe now it's by default enabled. We don't need to enable it. Okay. And
Okay.
yeah, we can go up to optimized level of fault tolerance, kind of, just to maintain the failure as well.
Okay, sir.
Okay, guys. So I'm